So this video lesson is an introduction to variables, some notation and terminology surrounding variables, and some of the basic ways that we're going to use variables in class this year. So before we get to variables themselves, we have to go over a few different pieces of terminology first. The first is an expression. And I'll tell you right now at the beginning of the video, there are lots of things for you to write down. This is probably one of the heavier videos that we do in terms of pause, write this down, but there are a lot of definitions because we're going to use those vocabulary words and that terminology to talk about things that we work with for the rest of the year. So first we have an expression. An expression is just a combination of mathematical symbols without an equals sign or an inequality. So go ahead, pause the video, write this down, come back when you're ready to move on. Now, expressions can be broken down into two types of categories. First are numerical expressions. That's just an expression containing only numbers and operations. I'll give you a few examples of this after you pause the video and write down numerical expression and its definition now. So anything that we have that contains only numbers and operations and doesn't have an equal sign or an inequality sign is considered an expression. For example, 5 is a numerical expression, contains only numbers. There's no operations, but that's okay because it contains only numbers and operations. Similarly, 12 plus 7 minus 9, that's a numerical expression because it's a string of numbers and operations. Similarly, 3 times 4 divided by 8, also a numerical expression, contains only numbers and operations. And so we could do a lot with numerical expressions. We've worked with evaluating large, complicated expressions with the order of operations, but now we're going to make it a little bit more interesting and introduce this thing that we call a variable. And a variable is just the term we use to describe a letter used to stand in for an unknown value. So go ahead, pause the video, write this definition down, and come back when you're ready to move on. So the first thing that we talk about when we talk about variables is the fact that it is, in fact, a letter. And almost always we use actual letters. Letters from the English language, we call the Roman alphabet. A's, B's, our favorite letter, which is X, that we use in algebra more often than anything else. I'll tell you the story about why we think X is used as a variable in class at some point. But X is what we'll use most commonly. Y is, for example, we also use in certain sections of math and certain sections of science. We use Greek letters as variables. For example, we use the letter alpha. We can use the letter theta, refers to angles when we get to them in a measure of angles. We can use the letter psi, which looks a little bit like a trident. We can use Roman letters, Greek letters, any letters that we want. There are a few exceptions, though. There are 4 letters that we cannot use as variables because they have values themselves. That is E, I, pi, and phi. Those are 4 letters, 2 Roman, E and I, 2 Greek, pi and phi, that we're not going to use as variables this year. We probably won't use a whole lot of Greek letters as variables. But we're not going to use E and I because they have specific values in algebra that you get to a little bit later on in your algebra career. Now, if we take things like variables and we add them to numerical expressions and suddenly we become a combination of variables, numbers, and operations, we could call that then a variable expression. So go ahead, pause the video, write down another definition, variable expression, and come back when you're ready to move on. So again, like a numerical expression, this is just a string of numbers, operations, and variables. Anything from 3x is a variable expression. 3x plus 7 minus z is a variable expression, etc. Just a string of numbers, operations, and variables. Now there are 2 particular things that we're going to talk about with variable expressions in this video. But the first thing that we have to do, now that we have all that terminology, is talk about what we call notation. And notation is just an accepted way of writing something down. And when it comes to variables, we have 3 particular types of notation that we're going to follow for everything that we do. The first is anytime, before we get to that, anytime you see a number or one number or a number, different number. Those are all going to represent variables when we try to write an expression. So if we have 3 times a number, and let's say we're going to go with our favorite variable x here, 3 times x, we write that as just 3x. A number and a variable smashed together with no operation. That is going to be 3 times x. A variable will never, ever, ever be used to substitute for a place value in math class, and is rarely, if ever, used to substitute for a place value anyway. So if you see something like that, it's not 30 something where the something is unknown, it's 3 times x. If we have one number and a different number, we just have to give them different variables. So one number, let's call it a, times a different number, let's call it b, we can just write them as ab. That is a times b, one variable times a different variable. If 2 variables are the same, that means they have the same value. If they're different, they may have different values. And finally, on the right, a number divided by 5. When it comes to division with variables, we use a fraction bar. We're not going to use the division sign because fraction bar is more commonly used in algebra, in calculus, and anything that you're going to get to. The division sign sort of falls out in favor of a fraction bar. So we're just going to get used to the idea that that's coming up by using a fraction bar. So those are the 3 important notation things that we have to use. We're going to use them in everything that we do with variables throughout class. So 2 things we can do with variable expressions from the get-go. First is we can write them from verbal phrases. We've been doing that when we talked about notation. Things like a number minus 6, literally left to right, a number minus 6. And that's all we got. 3 times a number added to 12. 3 times a number added to 12. Notice that it's not 3 times a number plus 12 in parentheses because there are no parentheses there. It's just 3 times a number all added to 12. So go ahead, pause the video, write down these 4 verbal phrases as well as the variable expressions that go along with them, and come back when you're ready to move on. So from top to bottom, the quotient of a number in 16, division is ordered. So we read from left to right, a number and 16, x divided by 16. The difference between 10 and 4 times a number, difference means subtraction, and subtraction is also ordered. So we have to move from left to right between 10 and 4 times a number. 10 minus 4x. 11 plus, in parentheses, a number divided by 3. So 11 plus, we can add parentheses if we don't. If we want to, we don't have to because the order of operations would tell us that division comes first anyway. And finally, the sum of 17 in a number is about as straightforward as we can get. The second thing we can do with variable expressions is what's called evaluating them. Now, we talked about evaluating expressions earlier in the year. To evaluate a numerical expression, for example, to use the order of operations, means to perform all the calculations to arrive at a single value for that expression. Same thing is true for variable expressions. We just have to give the variables specific values. That means if we have x's and y's, we have to give an x a particular value. We have to give the y a particular value. And then we can calculate the value of the overall expression the same way that we've done in the past. So, for example, if we have 2x plus y, where x equals 10 and y equals 3, that's 2 times x, so 2 times 10, which is 20, because that's what x is. And then finally, y equals 3, so that's 2 times 10 plus 3, or 20 plus 3, which is 23. That is the value of that expression when x equals 10 and y equals 3. So go ahead, pause the video, evaluate these 2 expressions using x equals 4, y equals 6, and z equals 9. Remember that 2 variables smashed together, or a number and a variable smashed together, means multiplication, and come back when you are ready to see the answers. So for the first one, xy is x times y. That's 4 times 6, which is 24. All that is subtracted by 9. So 24 minus 9 is 15. And for the one on the bottom, 3 times x, which is 3 times 4, is 12. Minus 2 times 6. 2 times 6 is also 12. Remember, order of operations. The groups before the subtraction, 12 minus 12 is 0. So that's our introduction to variable expressions, writing them, terminology, and how we evaluate them when we give variables specific values.